Okay, hello everyone. So now this is another video on alligation. Now today we're gonna be talking about forward indexing method, and we will use the example we used in the last video. So now here we will have 1, 2 until 3 parts. The third part we are going to sketch or to describe the proof of this forward indexing method, but the proof will be done properly in another next video. So now here we have this motivation. We start by the method we talked about last time. It is about the partial weighted mean unit value use method. So we have just this example about a mixture of we had a quantity, first quantity for first component of a mixture. The mixture was concrete. So from last time, so the first component was cement. Second component is sand. Third component, for example, is aggregate, coarse aggregate. Okay, now for each component, so we have some price. Price 1, like 200 by kilogram, for example. 200 francs by kilogram, say, for example. And the second one, 45, third, 50. Now, we had this equation. Last time we said that this equation where we desire the price, desired value, if we want, for the mixture. For the concrete. So if all 1, 2, 3, 4 values are known, now what will be the weight? Weight with indexing extending from 1, 2, and 3. Okay, so now the one of the answer showing infinitely many solution is that the first weight is given by this quantity, second one by this fraction, third one by this fraction. Okay, so last time we said that if you take x equal to 1 and y equal to 4, so we have found that the weight will be the ratio will be 1, 4, 2, 4, 2, 4. Okay. So we said we can choose other values. Similarly, so today we are going to see that now, okay. So if we know that if we multiply by x by the same value for this continuous ratio, we find another equivalent ratio like 2x and 4x for any non-zero value. This is also an equivalent ratio, even if we can choose arbitrary x, 1, 2, 4, and so on, a half, any value which is different from 0. So we have infinitely many values, but this value is equivalent to this, meaning that if you have this as this ratio, so this is also an equivalent ratio having the same result, depending on the quantities that we take for each component. But this infinitely many solution that we have here, we may associate other values of x and y and get a different value which is not equal to this one. So we have so many solutions. Now, if we want to choose one solution, we may take ratios of two consecutive, for example, weights, even if they are not consecutive. But the formula for forwarding indexing method, this method here, we set ratio to any value which is different from 0, of course, not equal to 0. And then we now calculate the weight in terms of those ratios. And here, for example, in our case, n is equal to 3. And here, in that case, if we have the first ratio, so we can calculate the second ratio. So thanks to this equation, and through this method, we can now give some examples in which we choose one ratio. We have two ratios for n equal to 3. We have R sub 1 and R sub 2. Here, R sub 1 is equal to first weight divided by the second weight. So R sub 2 second ratio is second weight over third weight. So if we take product of the ratios, so we are going to find is the first ratio divided by the first weight divided by the third weight. We can verify here. If we take omega 1 over omega 2, which is the first ratio, multiplied by second ratio, which is the second weight over third rate. So we can simplify and find that it is omega 1 over omega 3. So which is the product between the two ratios. Now these two ratios are enough in order to find the overall ratio, this continued ratio, which can take either this form or that form. And in terms of the ratios, we have this quantity, this expression. And now the weight, as we said, weight can be expressed in terms of the 1-2 ratios, in this case of index n equal to 3. Okay, so now this means that here we have the first weight will be product from j equal to 1 until j equal to 1 minus 1, reciprocal of these ratios. Okay, and that one will be equal to, okay, so I have to divide by the sum of all reciprocals and their product, divided by sum. So let sum. Okay, sum. Let me extend because you have an index which is not big, so I can try to put these ones. This product g equal to 1 until g equal to 1 minus 1 reciprocal. Now plus because it is from this sum operator, and plus product g equal to 1 until j equal to 2 minus 1, reciprocal of the ratios, these ratios. Now plus finally product operator, so j equal to 1 until j equal to 3 minus 1. Now here here omega 1 will be equal to, so this quantity, so it will be a product from j equal to 1 until j equal to 0 of the reciprocals of the ratios. So, so in this case, so we have product from j equal to 1 until 0, reciprocal of the ratios, plus product from j equal to 1 until j equal to 1 of the reciprocals, plus finally this one, product j equal to 1 until j equal to 2, 3 minus 1 is equal to 2, reciprocals of the ratios. Okay, now can I remove this and try to compute this? Now here is the rule. So the rule, so for any indexing, if we make product from 1 until 0 from of the reciprocals of the ratios, for any index, this quantity is always equal to 1. For any index for any index n, here we took index 3 because you have 3 components of the mixture. So now here, for any index even greater than 3, so we always have this one. This is one of the properties, so we're gonna prove in the next video. But for this video, let us now look at the result we're going to get. So here we comply that this is, we understand that this is equal to 1. Now, and then this one also will be equal to 1. Now here, this, because we no longer have any indexing except 1, we have 1 over the first ratio. Okay, so now here we take the product from j equal 1 until 2, which means we have 1 over the first ratio times 1 over the second ratio, and this gives me the first weight. How about the second weight? The second weight will be, of course, this one over this. The same. They have the same denominator. The 3 weights: first weight, second and the third weight. They have the same denominator, which is this combination. Now, this means that in that case, so we can find space here in order to write the second weight. Second weight will be, so the same denominator, 1 over R1 plus 1 over, okay, put them together, R1 times R2. So this will be the second term here, 1 over R sub 1. So what about the third weight? Will be same denominator, 1 plus 1 over R1, R sub 1 plus 1 over R1 times R2. So the third term is 1 over R sub 1, R sub 2. So these are the 3 weights, that the third weight that we are going to obtain, the second weight, and the first weight, first, second, third. Okay, now what will be now the ratio? The ratio will be, so the ratio, it will be this one. Because this ratio is equivalent to the ratio where we have first weight, 2 second weight, 2 third weight. So this one will be equivalent to, in this case, it will be equivalent to this ratio also. Okay, now, but here, it is in case we know the one of the two ratios, either R sub 1 or R sub 2. Suppose now we have R sub 1, its value. Suppose R sub 1, suppose is equal to 1 over 2. So now the question is, what will be R sub 2? And if we have the two ratios, and we are going to get the continued ratio, overall continued ratio. So that is the first question. So now, second question will be, so if we have R sub 2 equal to a half, so we are going to obtain also, we are going to find R sub 1 in this case. So that is first question. So let us continue. Second question, if we have R sub 1 equal to 1 over 3, what will be R sub 2? Because if we have the two ratios, we're going to have the overall ratio. Okay, so that is number 3 here. So number 4, if we have R sub 2 equal to 1 over 3, what will be R sub 1? Okay, we consider 1, 2, 3, 4 questions. So the first question, I hope we know all of this. Let us answer to the first question. Let us try to answer the first question. So you will see that the first question, we have already done it in the previous video, but using the weighted mean, partial weighted mean unit values method. Now, let us now use these results and try the first question. Now, if R1 equal to a half, this means omega 1 over omega 2. So this is the same as, if we take this one, we divide by this, we get 5x plus 2y over 26x. Now, this is equal to a half. Now, we can solve this question for value of x or value of y. And we get, if we have cross multiplication, we get 26x, this one, is equal to twice 5x plus 2y, which becomes 10x plus 2 times 2 is 4x. Now, 4y, sorry. This is 4y. So now we can try to, so we have one equation with the two unknown, which means one of them may be a parameter. So we have 16x equal to 4y, which means that if we take x as a parameter, you can fix it, x equal to x, any real number different from 0. Now, what is the value of y? Y is equal to 16 over 4 is 4x, sorry. So now, for these values, we can find this ratio, this ratio, this R2. So R2 R2 is equal to omega 2 over omega 3. So omega 2 divided by omega 3 is equal to 26x divided 13y. 26x 13y. So this is the same as 26x divided by 13y. 13y is equal to 4x. So this, upon simplification, we are going to get 26 is 2. This one will be equal to, upon simplification, let us see what R2 will be. 26x over 52x. So now upon simplification, this is like 22 times 13x divided by 4 times 13x. So we can simplify x and get 2 over 4, and it is a half. So which means that our answer for this, the first question, so whenever we have R1 is equal to a half, so R2 will also be equal to a half. Now that is the first question. First question is answered. Now, so to these two ratios, we can calculate the ratio. So ratio will be, here we substitute the value of x we don't need, value of y, so it is 5x plus 2y, 2 times y. So y has been calculated to equal to 4x. So divide or 2, 26x, 2, 13y, y is 4x. So this is the same, this ratio is the same as 2x, 8x is 13x, and 26x, and 52x. So this ratio, for any x different from 0, is equivalent to this one. When we take 1 here, this is rho equal to, let us use the formula for from forward indexing method. This is 1 over R1, 1 over product R1 times R2. Okay, it is the same ratio in the sense that R1 is half, this half, so reciprocal of a half is 2. So now product of the two one, because the second ratio is a half. If I get a half times a half, it is a quarter. A quarter, reciprocal of the quarter is 4. Okay, so this ratio is also equivalent to this one, is equivalent to that ratio. This means that I can even multiply by some value, like any value you want, even z times z, twice z, for z, whenever z is different from 0. So it is also the same. This ratio is equivalent to all of these, even this one, or this, or this, or that one. They are equivalent. Okay, so that is question number 1. Let us move to question number 2. So here, so knowing the value of R1 for the first question, so we have find the value of R2, and then we can find the ratio over here. Okay, so number 2, let us answer question number 2. question number 2. So question number 2, we have given value is the second ratio. Second ratio is half. So we know that second ratio, half is ratio R sub 2 is W3 2 over sub 2 over omega sub 3. Let us use omega instead of W. So now we will have, this is the same as this one divided by that is 26x divided by 13y. Okay, so cross product, you get 13y equal to twice 26x. So now we have 13y is equal to 52x. So once again, we can find, this is to say that y is equal to simplification 4x again. So which means that this will lead us to find R1, which is equal to omega 1 divided by omega 2. This is equal to 5x plus 2y divided by 30, no, sorry, divided by 26x. 26x. Okay, so now this is going to be equal to 5x plus 2 times 4x divided by 26 times x is same as same as 5 8x divided by 26 no 5 plus, sorry, 5 plus 8 is 13x divided by 26x, which is equal to 13x over twice 13x. Upon simplification, we get a half or so. So this brings us to the answer of this question. When R2 is a half, R1 is going to be a half also. Okay, so this gives the same ratio as here. Now we can tick to be true this one and move to the third question. Third question. Move quickly. Talk about the third question. So I can remove these ones. So the ratio involving these ratios, these overall ratio involving these partial ratios. So it is the same for all 1, 2, 3, 4 cases, because this is a formula for forward indexing method. Okay, this is the reason why I'm not removing. I can remove everything else, but everything else stays the same. Now let us look for question number 3. Number 3 here, we have if R1 is equal to 1 over 3, what will be R2? Okay, so in that case, this is the question here we are solving. This means that 1 over 3 is equal R1. First ratio is omega 1 over omega 2, which is 5x plus 2y over 3, over the same denominator will cancel, and we have over 26x, which brings us to the 26x is equal to 15x plus 6y. So fixing x as a non-zero number, real number, and then we can calculate value of y. So y of y is going to be equal to 26x minus 15x divided by 6, and this is equal to difference is 11x over 6. So that is the value of y. Now, as you want the ratio, the second ratio is omega 2 over omega 3. So this is equal to omega 2 over omega 3. So 26x divided by 13y, because the same denominator will cancel out, will be cancelled, and then result is 26x, and we have 13 times y. So y here is 11 over 6. So now 6x, of course. Now x and x will cancel, and here we can simplify. This is 2. Okay, let us write x once again, and 6 here, it becomes 12. Then you have 11. So this 11x, of course. So now this is 12 over 11. So that is the second ratio. This means that if you have first ratio is 1 over 3, the second ratio will be 12 over 11. So here we can write down its value is 12 over 11. Okay. Second, first ratio. Okay. Now, how can we write now the weights? The weights or the ratio if we want, because weights, okay, weights we substitute differently, different values of this weight, or we can calculate a ratio and find weight after, because you know that weight for any case is using this forward index method is it is equal to product from j equal 1 until j equal to k minus 1 reciprocals, product of reciprocals of ratios divided by sum from I equal to 1 until I equal to n is equal to 3, product j equal to 1 until j equal to k minus 1, reciprocals minus 1, reciprocals of ratios. Okay, now either we first calculate weight or we first calculate ratios and weights after. Okay, so ratio here, in this case, in this second case, it is equal to 1. 1 over the first ratio. First ratio is 1 over 3. Second 2, 1 over, so 1 over 3, first ratio, 12 over 11, second ratio. Okay, so now this ratio become 1, 2, 3, 2. Now after simplification, this is 4, that's 11 over 4. Now this is to simplify. Let us write, we can simplify, and by doing so we have 4, 12, 11. Okay, now if we can use this ratio also to calculate back the weight, or we can use this formula, but they are equivalent in sense that if I want the first weight, because this is also equal to first ratio to the second ratio, to the first weight, to the second weight, to the third weight. So these ratios are equivalent. Okay, now in this case, let us calculate the weight. weight, either we can use, we can fix x and use y equal to, as we have found, 11 over 6. 11 over 6 x. And then we find first weight is equal to 5x x plus 2y. 2 times y is equal to 11x over 3. Now here it is at 1x plus 15 times over 6 simplified by 2 is 5. 511 it is what it is becomes a bit complicated, because I will have to find 15 times y. So y, I mean this quantity, y is 12. No, y is equal to 11x over 6. Now this is like 3, no, 5, 1 x over 2, over 2. Simplification by 3. Divide by 3 is 5, divide by 3 is 2. Then you have 55 x over 2. So this one is going to be 15x plus 11 x divided by 3 times now 2 over 62x plus 55x. So what we get here, omega 1 is equal to numerator 15, 11. Sum is 26x. I multiply by 2, I divide by 3. Here I divide by 62 plus 55. It is 7, then 11. 117. I hope this is correct. Then times x. Now this is equal to 52 over 117. 117 times 3, so it is 21, 5, 3. So 3, 5, 1. Is there any simplification? Okay, let us see if we can factor it as 3. As okay. How should I simplify? Do we have a common factor? Okay. Let us see if we can find common factor. Common factor. Let us see if we have 13 as a common factor. So this is we can take 351 divided by 13. So will be 1 or 2. 26. Difference is 9, 1. Luckily. So I have to put 7. So this is 13 times 27. Okay. So because here we have 91, then difference is 0. Now, so simplification. So I have 4 over 27. Okay. 4 over 27. But it seems it is a very long process, while I should have used these coefficients and get the first weight. And how can I get this? I'm still at the third question. Let me use a shortcut here. I'm using a shortcut in order to get the same weight. Okay, here this is okay. This is still okay. So the same weight. I have obtained omega 1 is equal to 4 over 27. So I should have obtained the same quantity by taking 4 plus 4 divided by 4 plus 12 plus 11, which is 4 over. So that is 16 plus 11, which is 4 over 27. Okay, so omega 2 is now it is 12 over over 27, and omega 3, this is equal to now 11 over 27. So meaning that substituting into this one, we get the equation. These weights will satisfy these weights, omega 1, omega 2, omega 3, will satisfy this equation. Okay, so now moving to question number 4. Okay, question number 4. I hope everything was understood for question number 4. I think I made a mistake here. This one should be here. This ratio, 12 over 11, should be for not for R sub 1, but here it is 12 over 11. Yeah, it must be here. Get R sub 1, R sub 2 equal 12 over 11. That is the end of the third question. Now, let us move to the fourth question. Now, first question. So we can remove everything else except this, because this is the forward indexing method. The formula is the same. It is this one or this one. For weight, here for ratio. Okay, so now here, now question number 4. So R sub 2 means the second weight. So the second weight, it is like 1 over 3 is equal to second weight is no, second ratio is second weight over third weight. This is 26 over 13. Is it what? We may run into trouble if we mixed up the result, but I don't think so. We have the situation here. It is we get 26x, we divide by 13y. So this means if we take cross product, 13y is equal to 26 times 3x. Okay, that is 13y is equal to 13y. 13y equal to 26 times 3 is 78. So value of y is 78 over 13 times x. And what is this? This is 78 common factor if it is 13. So what will be this one over 13? So it is 2, 3, 4. Oh no. 1378 divided by 13. Let me just, I don't find myself. So if I take 6 times 3, yeah, that is 6. Okay, it is 78, and the result difference is equal to 0. Okay, that is it. Let me remove this for better clearance here. So we forgot factor x, which means, in other words, here y is equal to simplification. We have 6x. In case we fix x to a non-zero value parameter. So we have these results, and in that case, we can have the ratio by substituting. No, this is the ratio for a different. No, this is not a general one. A general one is this one, I think. Yeah, this is a general one. Now, this ratio, even this is not general. The general one is this one. Okay, I remove this one. The general one is this one. For this question, in general, we have this situation as for weight, we have this result. Okay, so now value of y is 6x. Now, what will be the first ratio? Okay, first ratio, r sub 1 is equal to omega 1 over omega 2. This will bring us to 5x plus twice y divided by 26x, because the denominator is the same. There's a cancellation. Now, substitution, 5x plus 2y, 2 times 6x divided by 26x. This is 2 times 6 is 12. Then we have 17x. 12 plus 5 is 17 over 26x. Okay, this is the first ratio. So now this is like 17 over 26. Okay, that is the result, 17 over 26. Okay, now here, this is the answer for question 4. Okay, now back to calculation of the ratio. So ratio here, in this case, question 4. So we have 1 over first ratio. First ratio is 17 over 26. It's gonna be 26 over 17. So product R1 times R2. Since we have R1, 17 over 26. R2 is 1 over 3. So this is gonna be 17 over times 78. Okay. Now we have, this is gonna be 7. Now we reverse, reciprocal is 78 over 17. So which means that for simplification, let us take 17, 26, 78. This is the ratio for the fourth question. So now we can, from this, it is simple to calculate these weights, which will verify this equation where unit values are known. Okay, let us, for this, to finish up this question number 4, let us now use these weights. this ratio, and then calculate the first weight, for example. So first weight will be 17 over 17 plus C 26 plus C 78, which will be 17 over calculation. Let us calculate here 78, 26, 17. Adding up will be 14, 21. Now here 10, 12. So now this is 12, 1, 1 to 1. So this is the first. Second, now second, we no longer need to calculate the denominator, is the same. Numerator is 26, and the third weight 1 over 2, 1, and 78. Because these are the three weights. Those three weights must verify this equation. Okay, now we can verify if this is correct. It means this combination, the sum of it must be equal to the mean value, which is 70. And this must be the same for each case we discussed, the first, the second, third, and that the last. Let us do it for the last one, verification. So we want to calculate omega 1, P1, omega 2, P2, omega 3, P3, and find its value and verify it is equal to the mean value of the mixture. So this is equal to omega 1. Let me use this color. No problem here. Use this color. Omega 1 is 17 over 1 to 1 times P1. P1 is 200 plus now 26 over 21 times P sub 2 is 45 plus C now over 21, what, 50 times 78 times 50. Okay, so in this case, let us make calculation here. So here it is not difficult as such, but everything else we're gonna divide by 1 to 1. So here it will be 3400, 45. Let us do here 45 times what? 26. What is it? 13. Carry 3. 24, 27. Now 25 it is 90. Adding up it will be 1170. So this plus 17 1170 plus. Now we're gonna have to multiply now. This must be simple since it is 78 times 5. It's going to be equal to 40. I carry 4, 35, 39. So I have to add another 0. Okay, so now this is the combination that I need in order to get the unit mean value, unit value if you want. And then we have 1 4 0 0 3 9 0 0, then 1 1 7 0. This is 0 7, then 14 1. I carry 1 and get 8. Okay, now this will result into 8470 over 1 to 1. Now So again, let me do some calculation. For division, I have to divide 8470 divided by 121. So I'm expecting the answer to be 70. Reason why I can put 7 and check. 7 times 1, 7 times 2, 14. I carry 1. 7 times 1 is 7. Plus 1 is 8. Then if I subtract, I get 0. Reason why I have 70. So this is exactly equal to 70. The same checking should have been done for each 3 other cases. The third, the second, and the first. And the result must be, so this equation should be verified. Okay, now we have just come to the end of this video using forward indexing method. Now, what we need to do next time we are going to just this was like an introduction of this forward indexing method. So next time we're gonna be talking about the proof forward indexing method. Description. So we are going to describe this method next time. So we will have like 4 propositions. We are going to prove first proposition. We will prove that for each quantity. So in general, omega k is equal to, if we know the quantity for the component, for any given component, the first, the second, the third, and so on, it will be equal to the ratio between the quantity of each component to the sum of all quantities. So this is the result, and this result we will see that these weights are normalized, which means that if we add them, second, third, and so on, because we want to have a general case until the last index, suppose n, this must be equal to 1 in general. That is the first proposition we are going to prove. Second proposition number 1, it will be this one. Okay. Now proposition number 2. So we are going to see that if we know one quantity out of a list of quantities for each component, so we can calculate them if we know one of them, provided some quantity of ratios, some number of ratios are given. And here we have, for each quantity, we can use the first one, for example, in order to calculate others. If we know k minus 1 in reciprocal of ratios. Here, ratios must be at least, if we know, here it extends from we have n minus 1 ratios to until n minus 1. But in order to calculate this one, what is required is we require only n minus 2 ratios Rj. Because if we know n minus 1 ratios, we can calculate others by using this equation. Okay, those are the two propositions. And the third one, let us calculate the third. The third one. Proposition number 3. Proposition number 3. So here we're going to prove this formula. Each weight, the weight is given by product of ratios from 1 until j equal to k minus 1, reciprocals of ratios. Okay, so divide by sum of these ratios from the first one, which is so in particular is equal to 1. So then we have I minus n, sorry, until I equal to n of now product j equal to 1 until j equal to I minus 1. That way I was confusing this. In reciprocals of the ratios. So for indexing k standing from 1 until 2, 3 until n. For any finite indexing n integer value, positive integer value. Now here, this brings us to the last one, the last proposition, proposition number 4. We are also going to prove this. It is that we have the ratios. Ratio is just we are going to have a product from j equal to 1 until j equal to 0, reciprocal of j. This we said is equal to 0. 2 from j equal to 1 until j equal to 1, reciprocal Rj. So 2 j equal to 1 until j equal to 2, reciprocal of ratios, and so on until you divide by j from 1 until j equal to n minus 1, reciprocal Rj. So here, this is the property, the last property, but which is somehow is not needed if you know proposition 3. But proposition 3 is not necessary if you know proposition number 4. Next time we're gonna prove all these 4 propositions and see one formula which will help us to recover if you have n minus 1 ratios Rj, n minus 2, n minus 2. If we know n minus 2 ratios Rj, in this case, we can use this equation. It is the same as this, and we recover one which is missing in order now to find all weights or the continued ratio. So until then, keep watching. You will understand fully what all problems about alligation. So next time.